Hey guys, Mr. T here. So the last little bit in your matrices topic is costing and inventory problems. So matrices are most commonly used in real life by shopkeepers, keep track of stock they have. This sort of question is called a costing and inventory problem. And it's important for shopkeepers to do this to ensure they have enough stock to sell to customers, and also make sure they don't have too much stock so that they waste money on the storage you would require to have that stock. So this is a real world application of matrices. As I've said before, matrices are just tables with all of the fluff around them taken out. All that's important really in a table is the numbers inside. So the key to doing these questions is understanding how matrix multiplication works again. It is the rows multiplied by the columns and then add together the results. You need to be able to read the question and create a cost matrix that reflects the costs of stock being sold or bought. And lastly, you need to be able to create a requirements matrix or needs matrix that reflects the number of items being sold or bought. So basically, you need to know how many things you want in the requirements matrix so that it can be multiplied by the cost of the things you want. When you add them together, when you add the result of the rows times by the columns product together, you'll get a total cost. So it's meaningful once you've multiplied. So the only way really to get the hang of this is to run an example. So the example here, we've got Caroline and Nikki are both planning to hold New Year's Eve parties. Caroline needs 15 streamers, 3 party hats, 7 packets of party poppers. Nikki wants 2 packets of streamers, 5 packets of party hats, 12 packets of party poppers. The prices at 2 different stores, are store A and B, are this. So this is the costs matrix. We're going to need to form the requirements matrix using these numbers here. So part A, we need to produce a price matrix from the store A and B pricing information. So we need to, it's already in a table. So really, you've already got the possible matrix here. If we did that, the first row was store A, it would literally just be that table again, but written in matrix form. So bottom line 2.80, 2.50, 5.95. Now what I've said previously is that you need to keep in mind how matrix multiplication works. And the direction of the multiplication determines whether we're going to get the right answer or not. So at this stage, you do also need to acknowledge that the matrix might actually be in this vertical direction instead. It's the same information, but what if it was vertically aligned? We don't know at this stage yet which of these is correct. We're only going to know when we need to apply the multiplication and see which one works out or not. I think both of these would be acceptable answers because you have transferred that information from the pricing table to a matrix that contains that same information in the same columns and rows, okay? So at this point, we'll say that both of those are right. Produce a requirements matrix R, including both Caroline and Nikki's party needs. So I'll need to keep that on the same screen. Again, this is going to be 2 possible solutions. What if we did Caroline on the first row? So she needed 15 packets of streamers, 3 packets of party hats, 7 packets of poppers. And Nikki on the second row, 2 packets of streamers, 5 party hats, 12 party poppers. We don't know at this stage yet in what direction we need to do the multiplication or whether it will work or not, or if we have the right orders to perform multiplication. So that same information could be put in a matrix like this vertically instead. It's the same information just done in a different orientation until we actually need to do a multiplication and work out what way they need to go. So at this stage we're accepting both. So now we need to find what R times P is. RP is going to be, so in previous lessons, in previous videos, we have said they can only be multiplied in particular circumstances when the order, with the number of columns in the first has to be equivalent to the number of rows in the second. So the order of the price matrix, the horizontal one, is 2 by 3. The order of the vertical one is 3 by 2. The order of this first requirements matrix is 2 by 3 again. The order of this other orientation for the the requirements matrix is 3 by 2. So having a think about that, you cannot multiply those. You cannot multiply between those two because the number of columns in the first 2 is not equivalent to the number of rows in the second. I'm saying first and second because we're doing RP here. So there's an order to that. I can't do these two. Cannot happen. Because the number of columns in the, columns in the first is not equivalent to the number of rows in the second. We can, however, do the requirements matrix 2 by 3 multiplied by the price matrix 3 by 2. So, because we've confirmed that can happen, we can go through with it. 15, 3, 7, 2, 5, 12 is being multiplied by 3.95, 1.90, 5.35, 2.80, 2.50, 5.95. And now thinking about how the multiplication happens, this is, let's check the names again, Caroline's requirements. This is the materials she needs. And in matrix multiplication, it's the row times by the column. So what's going to happen when we multiply these? If you times that row by that column, the sum of it is going to tell you how much Caroline spent in shop A, because this column is shop A's prices. If you multiply the next step, it would be this row times by this column. That would tell you Carolyn's total cost from shop B. And then the same would be on the bottom row. This is Nikki's requirements. If you multiply that row by this column, the sum of it would be the total costs for Nikki at shop A, and then the last multiplication that would happen is this row by this column, and that would tell you, when you've summed them together, the total cost for Nikki at shop B. So, once again, what you can do is write the orders. So this is a 2 by 3. This one on the right is a 3 by 2. You can multiply them because these are the same, and the resulting matrix is going to be 2 by 2. So let's draw that here. 2 by 2. And so now, the solution to this, I need more space actually, so all the way like that. The multiplication is going to happen in this order, 15 times by 3.95 plus 3 times by 1.90 plus 7 times by 535. Next is going to be the same row on the left, 15 times by 2.80 plus 3 times by 2.50 plus 7 times by 5.95. So I'm going to just draw dots here so it doesn't get all mushed together. The third multiplication is going to be the second row of the first matrix times by the first column of the second matrix. So it's going to be 2 lots of 3.95 plus 5 lots of 1.90 plus 12 lots of 5.35. Then the last multiplication is going to be the second row of the first matrix times by the second column of the second matrix. So it's going to be 2 lots of 2.80 plus 5 lots of 2.50 plus 12 lots of 5.95. So I just need to grab the calculator to answer this. Can't do any of that in my head. So 15 times by 3.95 plus 3 times by 1.9 plus 7 times by 5.35. It comes to 102.40. Next, 15 times by 2.8 plus 3 times by 2.5 plus 7 times by 5.95. 91.15. Third matrix multiplication, 2 lots of 3.95 plus 5 lots of 1.90 plus 12 lots of 5.35, 81.60. And the last matrix multiplication, 2 by 2.8 plus 5 by 2.5 plus 12 times 5.95, 89.50. So keeping in mind how the matrix multiplication happened, this is the result of, I think it's Carolyn's requirements matrix times by shop A's costs matrix. So this is how much Carolyn would spend at shop A. This is Carolyn's requirements matrix, requirements row, times by the shop B price column. So this is the total she would spend at shop B. This result is the result of the Nikki's requirements row times by the cost from shop A. So that is Nikki's total costs at shop A. And this last multiplication is the result of Nikki's requirements row times by the shop B prices. So using RP, what are Nikki and Carolyn's costs at store B? Well, we know that Nikki is the second one. Nikki spent $89.50 at store B, and Carolyn spent $91.15 at store B. So add them together, 180.65 total at store B. At which store should Caroline do her shopping? So where Carolyn's requirements row has been used is this top row here. So you're looking at whether shop A is cheaper or shop B is cheaper, and obviously shop B is cheaper. At shop B, Caroline spends only $91.15, so should shop at shop B. Checking if there's any questions under there. So that seems quite involved. It is just actual worked application in real life of matrix multiplication. Hopefully I've made it clear to you that if you're just asked to produce a matrix with information, there are alternatives. You could do it across or vertically. You could do this across or vertically. It's only when you need to do the actual calculation where you can determine which directions they have to go, because it's only going to work in a particular way. Firstly, you can't times these two with each other. You can't times this requirements matrix with this costs matrix. You can't times this requirements matrix with this costs matrix, but you can do this requirements matrix with that cost matrix. And when you check how they're going to multiply out, you can check in your head that the results are going to be meaningful. This line, this row times by this column is going to tell you Caroline's total cost at shop A. This row times by this column is going to tell you Caroline's total costs at shop B. This line times by this column is going to tell you Nikki's total costs at shop A. And lastly, this line times by this column is going to tell you Nikki's total costs at shop B. Hopefully that helps you out. And I will see you, well, I never see you, but I always say that anyway. See you in the next video.